So, welcome everyone. I'm sorry I'm out again today, but I will be back on Wednesday. There are new seats for both classes. This is first period and second or fifth period, and we're going to look through a set of notes to help you with parent functions. And so, this first one is just recalling the three functions we've already gone over. So, I would recommend jotting these into your notes. This is for objective 2 on describing functions. So this first one has a name. We've got the equation here, f of x is equal to x. This is called a linear parent function. And linear functions create a straight line, and they can be in any form, positive, negative, horizontal, vertical, but they create straight lines. The second form is f of x equals x squared, and that is going to be our quadratic function. And quadratic functions create a U-shaped curve that we call a parabola. They can be wide, they can be facing up, facing down, narrow, however. And the third one we looked at was the cubic function. This is f of x is equal to x to the power of 3, cubic. And the cubic function kind of creates a little, well, we call it an S-shaped curve, but it could have also been named an N-shaped curve with a capital N, like that. One of our students noticed that, and I like that little analogy as well. And the parent function itself, f of x equals x cubed, doesn't really look like it has an up and down part of it, but this is kind of like that little curve right there is that aspect. So when you go to graph that first one, it looks kind of like that. All right, after that, we're going to look at this function here. It might be tempting to call this the square root function, but we call it the radical function. The radical function looks like, well, we're going to find out. So we're going to start by graphing these functions here. I'm just going to do the first one for you, square root of x minus 4 plus 5. When you go into Desmos, to get the square root button, you're going to press this little button next to the volume on the bottom. So that's the square root. And then you can type in your x minus 4. Oops, it's not 5. Where's my delete? And then you want to move your cursor on the outside of the square root. So you can use this little arrow button to move yourself on the outside. And then you can type your plus 5. Now, as you can see with the square root, it keeps on going, but it definitely has this end point. And when I go to plot that point, I'm going to have it at positive 4 and 5. So that is our end point, is 4, 5. And so that's something to jot down in your notes, just as a little helpful reminder when you're graphing this. So it keeps on going out, and our endpoint is at 4, 5. So I would pause the video so that you can finish graphing the rest of these. And when you come back, I'll go over them. So when we look at this next one, it's a similar idea, except it's flipped upside down. And our endpoint is at negative 8, 7. And then this last one is the same as the first one, except I think it goes a little wider. So that would be another endpoint here at negative 3, negative 4. Now you might be seeing some significant, aspects of the endpoints compared to the equations. We're going to look at that another time. But the most important thing to see with the radical function is it does have an endpoint. So our endpoint is this little point right here, and it continues on in the other direction. I think of this as a swoosh. Swoosh. It kind of swooshes away like the Nike swoosh. I've got two more functions to look at. This first one, it kind of looks like x to the power of 3, except that 3 is on the inside of the square root. So this is called a cube root function. And the way that we do that in Desmos is you go into a new one. Oh, here, let's just delete out of these ones. And you click on this functions button and go all the way to the bottom where you see this n root in the middle on the bottom there. Press that, you're going to type your 3, and then on the inside, you're going to type whatever it is that they want. And I forget what the function was. So this first one is x plus 3 minus 2. So x plus 3 over, and then minus 2. So you want to make sure that minus 2 is not on the inside. And would you look at that? It kind of creates this backwards cubic function. And so our graph for this one would kind of look like that. And so you can carry on and graph the other ones, again, pausing the video to see what kind of graphs you would get. So this negative is flipping it upside down. And the 1/4 is kind of making it look, I believe that one is making it look a little bit more narrow. Oops, not that way though. I think it was the other way. This is positive. But in any case, you get this little kink in a line that kind of shifts it either above or below the original line. So that is the cube root function. And the last one we're going to look at is called the rational function. You might also see the term reciprocal. We do not like that one because the rational function has expressions on the denominators like this. So when we go to graph these ones, 1 over x plus 3 plus 2, when you type in 1 over x plus 3, oh, it does do it. Hey, look at that. I thought it would just do 1 over x and then the plus 3 on the outside. You're going to have to scooch your little cursor over to do the plus 2 like that. And you see that we've got these two graphs that keep going. You can go all the way out if you want, but what's the fun in that? And what you end up with is a graph that kind of looks like they're hugging these two curves. And that's because these are asymptotes. These lines that it doesn't touch are asymptotes. And when you find the domain and range for these ones, it's just a matter of saying that x cannot equal whatever number this one is, and y cannot equal whatever number that value is. So that's the domain and range. Like, you do not have to say all real numbers. You're just saying it cannot equal this value. So you can go through and finish up the others, pausing the video. And I think it should create similar graphs where it's still got the two asymptotes going through like that. But for this last one, since that negative is there, it's going to flip them where it goes like that. All right, so now you've got yourselves an assignment to take care of in Canvas. So the classwork objective 2 Kahoot parent functions. This is just reviewing each of these shapes. I believe I might have snuck in a tricky one with exponential. So you do want to look out for anything that's like a to the power of x. So a number to the power of x will create this little graph that keeps on going up and across like that. Just one of those, not like the rational functions where there's two of them. So you're going to be clicking on the link that corresponds to your period number, either period 1 or period 5, and that is for this first task.